So problem 52 is a little bit tricky for a lot of students because of the missing variables. If you notice, we're missing an x from the first equation, we're missing a z from the second equation, and a y from the third equation. And that makes it tougher than it should be for some people to solve. But remember, when we're solving a system of equations, generally speaking, what we want to do is we want to get, a smaller system. We're going to try and eliminate a variable from two of the equations and then solve those two equations for those two unknowns and then plug back into one of the original equations. This is actually kind of helpful. We've already got the y eliminated from this equation, the z eliminated from this equation, and the x eliminated from this equation. All we have to do is pick one equation and eliminate a variable. So my suggestion, let's pick this equation and eliminate the x from this one. What would I do with the second equation to get rid of the x from the third equation? Yeah, multiply by -2. So -2 times row 2 added to row 3 is going to look like this. I'll get -2x minus 2y equals -2 added to 2x minus z equals 0. And that collapses down to -2y minus z equals -2. If you look carefully, this equation just depends on y and z. And so does this one. So that's perfect. That's exactly what we needed. We wanted two equations with two unknowns, and we got it. In most of your work on these types of system equations, you'd have to do this process again to eliminate, x from this equation so that we could put these two together. But here's our two by two system equations. Y plus 2z equals -2. -2y minus z equals -2. You're free to solve these any way that you want. You can use addition, substitution, graphing, etc. And soon enough, we're going to come back and revisit this example and do it on our graphing calculators. For now, I think the easiest thing to do would be to multiply the top equation by 2. So we end up with 2y plus 4z equals -4. Minus 2y minus z equals -2. Add those two things together. I get 3z equals -6. So z equals -2. Yay. Great. Z equals -2 is one of our solutions. So let's circle that there. If I've got z equals -2, what should I do next? I got z equals -2. How am I going to solve for x and for y? Let's start here. Let's plug in z equals -2 into this equation, or you can use the second equation. I'll use the first one. And then solve for y. Y plus 2 times -2 equals -2. If I add 4 to both sides, I end up with y equals 2. Great. 2 down, 1 to go. The last one to deal with is figuring out what x is. You're going to have to figure out which one of these equations you want to use. It doesn't really matter. We know what y is, we know what z is, so plug into one of them and then solve for x. I think the second equation looks easiest, so plug into x plus y equals 1. That's x plus 2 equals 1. So x equals -1. And that's it. We're done. You've got x, y, and z. Or in the book, you'd see it listed like this: -1, 2, and -2. That's old school. That's doing it by hand with the methods that we did in section 12.2. So if you want to go back and practice that, you can. But what I want to introduce you to is how to do it on your graphing calculator. To start that, let me ask you to think about an equation that you could solve in a blink of an eye. 7x equals 28. Almost all of you have probably already solved it. X equals 4. You divided both sides by 7. But let me ask you to think of solving this a different way. Instead of dividing by 7, could I also have multiplied both sides by 1/7? Isn't that the same thing? And 1/7 is really the reciprocal of 7. So it's 7 to the negative first power times 7 times x. 7 to the negative first power times 28. When I multiply a number by its reciprocal, I get 1. And then my solution is just the answer to this, 7 inverse times 28. X equals, I'll leave it like that, 7 inverse times 28, that's 4. Now, obviously that's a lot more work than we need to do. But what I'm trying to do is set the stage for how we're going to approach this stuff on our graphing calculator. We're going to want to do the same kind of thing except with our system of equations, and that's going to rely on matrices. So let's look back at the original system of equations like this, and I'm going to write this in the form of matrices. So the first system of equations, or the first equation would be 0, 1, and 2. I'm just dealing with the coefficients. 1, 1, and 0. 2, 0, and negative 1. Those are just the coefficients of my system. I'm going to call this matrix A. Now, regrettably, if I stick with the general notation for this, then there's a little bit of possibility for confusion. This is your matrix A. That's going to multiply x, y, and z. And we call that matrix X, but we're using a capital X. I know it doesn't look all that great, but that's what we're stuck with. Equals B. And B is going to be the right-hand side. So it's going to be negative 2, 1, and 0. Okay, so great. Now we've written this using matrices. Now if you put up with just a little bit of explanation here, then we'll start working on how to solve this using a system of equations. First things first, I need to tell you how to refer to your matrix in terms of its dimensions. Its dimensions always put me in mind of RC Cola, which you can't really get around here very easily anymore. In fact, I had a student bring me a bottle from a vending machine in Michigan State that seemed to have it for some reason. But the importance about RC Cola is the order. Row and then column. When you're talking about the size of a matrix, you first mention the number of rows and then the number of columns. So matrix A would be a 3 by 3 matrix. Matrix X, what dimensions would it have? Number of rows, number of columns. So 3 by 1. And this is also a 3 by 1 matrix. So it's important to keep in mind RC Cola. All right, rows and then columns. So I'm writing my system equations using matrices. AX equals B. And I want to get X by itself. Just like a minute ago I was trying to get X by itself in the simple little linear equation. And what I do, I multiply both sides by the reciprocal here. I'm going to do that here. A inverse, somehow if I can find whatever this inverse is, A inverse times X is going to equal A inverse times B. And now you're going to get the How about the matrix equivalent of a 1 times x here? And when you multiply by 1, that just disappears. So here's our solution. It's going to be A inverse times B. And if we can coax the inverse out of our calculator, we can let our calculator do all this work. A inverse times B, that's going to be our solution. So the rest of what we're going to do is work on trying to figure out how to enter this stuff into our graphing calculators. So let's do that. Right above the x inverse key, you should see a key that says matrix. So how do you access that menu? Second, and then matrix. It should give you something like this. Now, those of you who have borrowed my calculator, you might see some stuff here already. That's okay. What we're first going to do is we're going to edit our matrix. So go over to the right. So cursor to the right 2 or the left 1. And then with 1 selected here, press edit. Your calculator is going to ask you for the dimensions. It's always row then column. Now for a square matrix, 3 by 3 is not going to make a difference. But just watch real quick if I did a 2 by 4. 2 rows, 4 columns. Or I can go back and do a 4 by 2. Oops, how about 2? So 4 rows, 2 columns, etc. It's asking you initially what's the size of your matrix. We want a 3 by 3 matrix. We're going to input this right here. So that'd be 0, 1, 2, 1, 1, 0, 2, 0, and -1. Okay, looking good. When you're done editing this, then you need to quit. So to quit this, exit the menu, you hit the second key, then the mode key. That'll exit you out of this. If you're not sure, if you're looking back on, I'm just not really sure that I typed in what I thought or wanted, you can check that, hit the second key, then the matrix key, and press enter twice. It should type out matrix A for you. And here's a good place I want to pause, make sure that everyone is where we're at right here with matrix A printing out. You able to get matrix A out? Sasha? Need some help? All right. Mimi, can you help out Sasha? Anyone else? I want to make sure that you're on the right spot here. Because next what we're going to do is enter matrix B. So second, then matrix. Let's now edit matrix B. So what you have to do is you have to go to the edit menu first. So cursor to the left once or to the right twice. Select the edit menu from the matrix menu. And then either type in a number 2 or just cursor down to select matrix B. Now, what's the size of matrix B here? 3 by 1. 3 rows, 1 column. So make sure you enter a 3 by 1. And then let's type in matrix B, which is -2, 1, and 0. Now what's going to happen is you're going to get really, really fast at entering all this stuff. And once we get through the first example or two, this stuff's really, really going to click. After you're done entering this, you can quit. So hit the second key, then the mode key. Let's go back and type that matrix just to see that we got what we think we got. So second matrix. This time, cursor down once and press enter twice. You should see matrix B. We're all same spot, matrix B? Sasha?
Yeah, it's fine. Mine doesn't come up like yours does. It just shows me like A and B. It won't show me like a picture or anything.
Might be an older operating system. Are you getting brackets instead of the nice one long tall square bracket? Are you getting a couple parenthesis type brackets? All right. Is there? But are you? Is it Showing you essentially what I have here, though? Okay. Well, let's keep going one last step here. The last step, then, is to calculate the solution to our system of equations. Is just type in A inverse times B. So one more time, go back to your calculator, to the matrix menu, second matrix, press the letter A, and now I want the inverse of that. Can anyone suggest where I could find the inverse? Yeah, x inverse. Exactly. This key right down here, midway down on your calculator. So press that. Don't hit the enter key yet. Let's type in matrix B. So go back, hit second, and then matrix. This time go down to B. Press enter. So I've got A inverse times B, and let's see what that gives me. Wow, -1, 2, and -2. Cool. That's what we solved for just a minute ago. We solved problem number 52 originally. -1, 2, and -2. So the inverse is right on the face of your key. Kind of kitty corner up a little bit from the number 7. So just type in matrix A and then hit the inverse, and then type in matrix B. You don't need to hit the times key between these. It understands that they're being multiplied. Are you able to get the solution here? Yes. All right. Cool. So that's it. That's a way you can solve these things on the graphing calculator. And this works for, you can scale this up or down to any size system of equations. I think there might be some limitation on your graphing calculator, but theoretically you can do this for any size system of equations. All right, let's try this again. Let's back up a step and do problem number 50. And we're going to run this one a little bit faster. So the system of equations in problem 50 is 2x plus 3y minus 2z equals 18. 5x minus 6y, whoops, wake up, minus 6y, yeah, how about a y here, plus z equals 21, and last but not least, 4y minus 2z equals 6. All right, let's apply a little Photoshop here, make that actually look like a y. So the first thing we need to do is we need to think of this as a system of equations. My matrix A is going to be the matrix of coefficients. James, what are the coefficients here for problem number 50? Good. Perfect. So that's our matrix A. Matrix X is just X, Y, and Z, or it could be R, S, and T, or A, B, and C, depending on what you have. But then we have the right-hand side, which should just be these, 18, 21, and 6. What we need to do is we need to go back into our matrix menu and change the matrices that we had there. We're going to change the matrices to reflect this new problem for A, new problem for B. So I'll clear everything out. Second, and then the matrix menu, or second X inverse. Go over to edit. Matrix A is still a 3 by 3 matrix, so that's good. We just need to type in 2, 3, -2, 5, -6, and 1, 0, 4, and -2. Yay. So that's matrix A. Let's type in, oh no, we got to quit here. The important thing is that before you start entering matrix B, you quit this. So we'll hit the second key, then the mode key to exit out. Then we'll jump back in with matrix B. Second matrix, go over to edit, and down to matrix B. Still a 3 by 1 matrix. 18, 21, and 6. When you get that entered, you can exit out. To solve here, my solution is this part right here. A inverse times B. So that's what I need to calculate. Matrix A. So hit the matrix button, second and X inverse. Type in matrix A, then the inverse, followed by matrix B. You do not need that times there. Wow. There we go. So my solution is 8, 4, and 5 for X, Y, and Z. Nice. Or not. Sarah, you're not impressed with this? You don't think it's really cool? And this?
I'm just shocked at how much we did by hand.
Like, why didn't you tell us this earlier? Yeah, well, you know, it takes a while to build up to this stuff. What I'm leaving out, what you don't see, is an immense amount of work here, Sarah, that you need to use to solve for the inverse matrix. That's actually a lot of work. Let me show you how to get the inverse matrix. If you just wanted to look at it, what that is, you hit matrix A, and then we'll type in the inverse, and just look at the inverse. The inverse isn't exactly really pretty. If I hit the math key, I can turn that into some fractions. That's the inverse matrix. Wow. That's kind of a pain. And you have to take that inverse matrix and then somehow multiply it by this. The operations of multiplication are kind of a pain, especially when you're multiplying matrices. But it's stuff that a computer is well suited to do. So, yeah. But we can kind of bypass that. I've given you a nice way that you can solve not only system equations in the 2 by 2 case, the 4 by 4, the 5 by 5, the 3 by 3, whatever size you need here. So it's pretty handy. Now you bring up a good question though. So why didn't you tell us this earlier? Well, there's a couple things that you need to keep in mind about solving system equations. Let's take a look at problem number 46. Let's see if we can't scale this process into doing problem number 46, which is 9x minus 3y equals 6, and 3x minus y equals 8. So if I'm going to use this process for solving a system of equations, what's my matrix A going to be in this one? Iris? Perfect. And B, of course, would be 6 and 8. So let's enter all that into our calculator. So hit second X inverse to get to the matrix menu. Go over to edit. What are the dimensions of matrix A? 2 by 2. 2 rows and 2 columns. 9, -3, 3, and -1. Exit out. Second, quit. Let's enter matrix B. Second, X inverse, over to edit. Matrix B. Sabrina, what are the dimensions of matrix B? 2 by 1, thank you. So in here I'm going to put a 6 and an 8. I'll give you a little reminder. One of the tricks that I've shown you is to pull up your last calculation. And my last calculation should be finding the solution. If you press the second key, then the enter key, no, not quite. I guess I'll do that a couple times. You should probably only have to do it once. do it a couple times, you should get back to an or A inverse times B. And when you press the enter key, what happens? What do you see? What's the solution? Error? Oh, singular matrix. What's going on there? There is something going wrong. Now keep in mind what you're doing when you're trying to solve a system of equations. What you're trying to find is where two lines cross each other. Now, it's great when two lines cross each other, but they don't always cross each other. There's things that can go wrong. So what do you think is going wrong in this case? How come I'm not finding a unique solution? Well, let's find out. Here's the graph of one of them, and here's the graph of the other one. Bingo. You're exactly right. They're parallel. So the lines don't cross each other. If you look back at the system of equations, you can kind of tell that. Because on the left-hand side, there's a nice relationship between these two equations, right? If you multiply this by 3, you get this, right? But if I multiply this by 3, I don't get 24. So that's why they're not the same equation, they're parallel equations. If I went back here and made that a 24, oops, not 24, 20, yeah, there we go, 24. Then the two equations are going to be the same. You get one or the other. They're exactly the same equation. So let's try this again with problem number 38. So the bottom line on problem number 46 is that the two lines are parallel, and what you could say is that the system of equations is inconsistent and independent. Independent because the lines are different. Inconsistent because there's no solution. So problem 36. 5x minus 10y equals, no, how about 5x minus 15y equals 10. 15y equals 10. And x minus 3y equals 2. Now I'm going to save you a lot of effort here. If you were to take the time to plug in your matrix system equations and hit x inverse or hit a inverse times b, you get the same error we just got. What do you think is going wrong with problem number 36? Yeah. If you take a look at this, thanks gentlemen, then if you multiply the bottom equation by 5, you get exactly the top equation, right? These two equations are essentially the same. So you're getting a dependent, consistent system. Dependent, consistent. But you can see that because one equation is just a multiple of the other. They're essentially the same equation twice. That's why you're getting this. And that's why if you try to solve this on your graphing calculator, you get that message again. Error, singular matrix. And we'll learn a little bit more about singular matrices in section 12.5. But going back to your question, this is part of why I couldn't show you everything right away in terms of the graphing calculator. You need to understand, well, what's going wrong when things do go wrong. And we'll learn more about what goes wrong in section 12.5. Are you comfortable with solving system equations on your graphing calculator? So that's the one thing that I definitely want you to get out of this. You should also get, a couple other little benefits of understanding independent, inconsistent, dependent, consistent again, etc. The big thing is to understand how to do these on a graphing calculator. So are we good there? Okay. For homework, this is section 12.4. try 25 through 33 and 37 through 43. Good luck on that.